Hello friends, I am Suman Saurabh and today I am going to inform you one of the important topics of engineering, that is engineering mechanics. So before going to inform you about engineering mechanics, I would like to inform you the hierarchy of this chapter, that is engineering mechanics. Friends, as you know, engineering mechanics is being divided into two parts, that is mechanics of solid and mechanics of fluid. Here we are talking about today we will discuss about one of the topic of mechanics of solid. So I will consider here only mechanics of solid, and further mechanic of solid is being divided into two parts, that is statics and second one is dynamic. Again, this dynamic is being divided into two parts, kinematics and kinetics. And today we will discuss about kinematics. Without kinematics, it is very difficult to understand the importance of kinetics. So we will discuss about kinematics. So let me go to that page to start. So before going to start the kinematics, first of all I would like to inform you the definition of kinematics. That in kinematics basically we are discussing or we are studying only about the motion of bodies without having the reference of mass and forces. I mean, kinematics deals only with the displacement, velocity and acceleration of the point of interest with a particular time. So what I said, basically in kinematics we will discuss only three points, that is displacement, velocity and acceleration with respect to time. That's it. So let me show you the graphical representation. Okay. So before going to tell you about the displacement, velocity and acceleration, I would like to make you clear point of view regarding displacement and distance. Suppose this is basically it is three-dimensional coordinate, x-axis, y-axis and z-axis. Okay, and one of the insect is at point 1 and its coordinate is x1, y1 and z1, and the position vector of this point 1 at the place where insect is resting is r1. Now as you know, the insect are अपने मन की करते हैं, so this it starts moving from here and it reaches at point 2 having the coordinate x2, y2 and z2. With the reference to that final point, that is 2, the position vector is r2. So the direct distance or the shortest distance between the point point 1 and 2 is called the displacement vector, that is denoted by S vector. And this point and the actual path which is traveled by the insect is known as distance. So here r1 is the position vector, that is initial, and again r2 is the position vector, that is final position vector of that insect, and s is the displacement vector. And again I have to say that s, which is displacement, is the change in the position from r1 to r2. So the s vector displacement is equal to x2 minus x1 I cap, and here I cap is the unit vector along x direction, y2 minus y1 into j cap is the unit vector along y axis, and z2 minus z1 and k into k cap, where k cap is the unit vector along z axis. So hope you have understood about the displacement vector. So now, as we know, velocity is the rate of change of position with respect to time. So by taking the limit at a small time interval, we can convert velocity vector is equal to dr by dt. Further, you can write dr by dt individually in x direction, y direction and z direction, or you may write like this: velocity v is equal to ui cap plus vj cap plus wk cap. Here u represents the velocity of that insect, particularly in x direction, and v stand for the velocity of that insect, particularly in y direction. W stand for the velocity of that insect, particularly in z direction. So you may write the acceleration. As we know, acceleration is equal to change of velocity. Now we are considering acceleration. We know acceleration is the rate of change of velocity with respect to time, and you may also write the double differentiation of position with respect to time. So further, you can write the double differentiation of position with respect to time in x direction, in y direction and z direction. So we can write, you can write, and we can, and I can write this acceleration vector is equal to ax I cap, ay j cap and az cap k cap, where ax is the acceleration of that particle, I mean that insect, in that particular x direction, y direction and z direction. Hope you have got it this point. This is the one of the important things what I have informed you right now. Let me go to the next page, and that page is about there is a question that we have to find the distance or displacement, and question is given that there is a two distance, that is r, 1r again, and particle again insect move in a semicircular shape having the radius 2r. Again it moves to 1r linearly, and then again it follows the semicircular portion having the radius r. So if we find the displacement, so we have to check it the shortest distance between these two, initial point this and the final point. So r 2r plus 2r plus r and plus 2r. So total displacement is equal to 9r. Hope you have understood how I am finding the displacement. So if I talk about the distance is 2r plus this half circumferential area, circumferential length, this radius, and again this half circular circumferential length. So by adding this, we can find the distance that in particle moves from initial point to final point. That's it. Now I'm going to discuss about very important things. Cases. That for case number first, I'm going to consider acceleration is uniform or constant. As we know, acceleration is the change of velocity with respect to time. So I have written as acceleration is being shown. So we can integrate this equation both side, and after integration we can get velocity is equal to at plus c1. Here c1 is the first arbitrary constant. So for getting the exact value of this equation, or getting exact equation, we have to find the value of this arbitrary constant. So I am going to apply the condition that at time 0 the velocity will be the u, that is initial velocity. So by putting this condition, we are getting the value of arbitrary constant c1, that is u. So by putting the value of c, we are getting the equation that is v minus u equal to 80. This is one of the important equation of the motion. So now again I can write this very equation in this form, that velocity is being written as ds by dt, and minus u is transferred to that equality sign, to the reverse equality sign in this side. So I can write ds by dt is equal to u plus 80. So again I am going to integrate this equation ds and t, which is in division form. I have changed this division form into multiplication form by converting their sides by sides. So after integration, we are going to find an equation that is as equal to ut plus half at square plus c2. Here again what we are getting, that c2, the second arbitrary constant. So again I am going to apply the same condition, that at initial time 0, displacement is 0. So by applying this condition, we are going to get the arbitrary constant c2, that its value is 0. So applying the value of arbitrary constant in this equation, we are going to get this very equation, that is as equal to ut plus half at square. This is again one of the very important equations. So again, as we know, acceleration is equal to dv by dt. I can use this term, that is dv into dt into, we can multiply ds or divide ds. So again the value will be same. You know better how it is being done. So what I am going to do now, you know better, ds by dt, ds by dt is equal to v. I mean change in position with respect to time is velocity. So I have written here v, and I have written the value of dv as usual here and ds as usual here. So as a student of science, or being the student of mechanical, civil, you have to know the acceleration is not only about dv by dt, but it can also be written as v into dv by ds, which has great importance in our study. So now I am going to proceed again. So let me change the page. So what I am going to get, that acceleration is equal to velocity into dv by ds. So again, by integrating both sides, I am going to get equation that is v square by 2 is equal to as plus c3. Sorry. So again I have to find the arbitrary constant, value of arbitrary constant, that is c3. So we are again going to apply condition, that is at time 0 displacement is equal to 0 and the velocity will be u, that is initial velocity. So again we are going to get the value of third arbitrary constant, that is c3, which is equal to u square by 2. So again I am going to apply or put the value of c3, and we are going to get the equation of this, that is v square by 2 is equal to as plus u square by 2, and by solving we are going to get this equation, that is v square minus u square equal to 2s. Again this is the third very important equation of mechanics. So this is the third very important equation which has great importance in the field of mechanics. So now many times students are getting confusion how and when this equation is being used. So I am going to inform how and when you people have to use this equation. So in first equation, what you are seeing that velocity, final velocity, initial velocity, acceleration, and time has given. So whenever you are going to get that in equation, well, yeah, either this has given, this has given, or either of these four variable is absent. So you have to use accordingly. Okay, hope you are getting. Again, you have to do the same in equation second. If the displacement, ut, initial velocity, time, acceleration, you have to find out any of this quantity, and these out of these four quantity you have available three variables. You can use this very equation. That's it. Again, you are thinking the same. You can apply this equation. This equation. So we have find out the three different equation of motions. Now I'm going to show you free fall. Many times what you are seeing, that students of children, what they are doing, they are throwing, or they are just releasing the ball from the top of the roof. And what is happening, I am going to show. That is, this is the position when ball is being dropped, and on that time the velocity will be u, that is initial velocity, and ball will be travel with the acceleration of g, that is the acceleration of gravity, and at the on the earth the velocity will be the final velocity, that is v, and the distance traveled by the ball is h. So in this whole procedure, all the direction, all the quantities have the direction in the same side, that is downward. So we can easily apply the equation, that is u, at the place of v we can write v u plus at. At the place of sa you have to use this very gravitation. So you can find out this equation. I hope you have got it. Now many times in the questions, what is being asked, what will be the final velocity of the particle when it reached to the bottom. So at initial velocity the velocity will be 0. By putting the value v equal to 0 in this equation number second, you are going to get the value of final velocity, that is v equal to under root 2gh. I hope you are getting. Now again there is one more case, that is velocity. When many times you friends might have played cricket. So many times what players are doing, they are throwing the ball just in the upward direction. So when ball will be thrown in upward direction, the initial time velocity, that is initial velocity, will be u, the final velocity will be v, h will be the final height which is being achieved by that ball, and g, that is the acceleration which acts on the ball. But we have to notice that the direction of this gravity is downward, while the direction of final velocity and initial velocity is upward. So you have to be careful during using the equation of motions. So here v is equal to u plus at, as you know, but here the gravity is downward, or you may say that the opposite direction. So you have to use sign convention. Either upward motion is positive or upward motion is negative. But mind it, when you used velocity v or u, that is upward direction, is negative, you have to use g, that is gravity, positive. And if you used v or u negative, then you have to use gravity that is positive. So hope you have got it. That is always you have to mind it, that velocity or gravity have different sign. in this particular condition. So by putting the value of these three terms variables, we are going to get this equation v equal to u e minus gt, h equal to ut plus half minus g or t square. So h equal to ut minus half gt square, or v square equal to u square minus 2gh. So again we are going to get a special condition. Many time in many examination that is being asked that what will be the maximum height which is achieved by the ball. So you know better, when ball will achieve the maximum height, on that very time velocity, that is final velocity, will become 0. So we can apply the final velocity v equal to 0 in the third equation. So we are going to get that the maximum height will be achieved by u square by 2z. This is beneficial not only in the field of solids, but this is also beneficial. This equation is also beneficial for the mechanics of fluid. Whenever water flow through the pipes which is being vertical, which is being put there vertical. So that's it. Hope you have got it. If you have any query, you should ask me, and I would like to clear it. So thank you. So thank you very much for joining me. Thank you.